Hello guys, welcome, vanakkam, vandanam, namaskaram. Today we are going to see semi-part 3 of molecular bases and inheritance. Okay, so where hnRNA is converted into mRNA. That is what we are going to see. See, by these three processes, okay, by splicing, by capping, by tailing, these are those three processes that how hnRNA is converted into mRNA. Okay, see. Now we are going to see one by one. First of all, let me just draw the structure. Like this only, hnRNA will be there. Okay, in this lightly arranged is there, right? This one, I mean this one is there, right? So this one is actually expressed sequence. Okay, this is exon. Okay, this is intron. Okay, wow. So the first is splicing, which means that this particular diagram is there, right? So this will be converted into like this. It will be converted. Okay, like this will be converted, and then these structures are there, right? So these structures are known as spliceosomes. Okay, splice. Oh my gosh, the spelling. Okay, spliceosomes. Okay, so spliceosomes are there, where these spliceosomes will be this spliceosome is there, right? So that will be cut by. Okay, so this spliceosome will be cut by, what is it? It is known as small nuclear ribonuclear protein. Okay, small nuclear ribonuclear protein, which is known as SNPs. I'm very hungry, that is why my face cut is very tensed. Okay, when I'm hungry, I'm angry. So yeah, so it is SNPs. Now it will be taken out. Then what will be there? Only exons will be there. Okay, only exons will be there. Introns will be not there. Only exons will be there. Introns will be there. Okay, so this is what the first splicing is. Splicing is this total thing. Okay, it's this total thing. That is what I've explained, right? So this is what splicing. Okay, I'm very sorry for this external noises. What can I do? I'm in such a place. I cannot delete these noises also. I'm not that good in editing either. Okay, so next after this we are having capping. So what is capping? Capping is actually, see, this is for the exon part. Okay, so to this exon, this in this front part here is what splicing is. Then after that we are having capping. So see, exon is there, right? So to this exon there will be phosphate added. Okay, it is not just a normal phosphate, it is known as methyl guanosine triphosphate. Okay, so methyl guanosine triphosphate. Okay, so methyl guanosine triphosphate. Okay, so this will be added by an enzyme called it. See here, what enzyme is there? SNPs is there. Okay, because small nuclear ribonuclear protein. That is what SNPs are. Small nuclear will be there. Yeah, so that is what SNP mean. Okay, here, coming to here, it means that methyl guanosine triphosphate is there. So yeah, it is being added by a protein or an enzyme or something. What is it? What it is added by? Okay, it is added by an enzyme called methyl guanylate transformase. Okay, so methyl okay, so guanyl transformase. Okay, transformase. Okay, so it is added by, see, methyl guanyl transformase is the enzyme that adds phosphate. Okay, that adds phosphate to this exon group. Okay, so phosphate is being added by what? Methyl guanyl transformase. Okay, see, it's very simple. Methyl guanosine triphosphate is what being added to this exons. So that is why in the nomenclature they have taken this methyl and guanyl as its prefix, and then transformase. This particular exon part is being transformed when this methyl guanosine triphosphate is being added to it by methyl guanyl transformase. Okay, so it is what actually known as capping. So since there is a cap that has got like a helmet, so yeah, so this is what known as capping. So after this, what is there is tailing is there. Okay, see, capping will be always done at the 5 dash. Okay, it will be always done at 5 dash. I like to write that at. It's very, I don't know, I like it. And also I like to write like the letter called X. That's also good. Okay, so at 3 prime. Okay, in this place tailing will be happening. That means, see, already here methyl guanyl triphosphate is being added. Okay, and also along with that okay, like this, amino acids will be also added. Acids will be added around 300 to 400 amino acids will be added. Okay, by the enzyme called poly A phosphorylase. Okay, poly A, actually it is just adenine, right? It is actually adenine, right? So it is added by poly A phosphorylase. Okay, poly A phosphorylase. Okay, so poly A phosphorylase. A means adenine. Okay, or amino acids you can take it as. So poly A phosphorylase is the enzyme that is responsible for the addition of amino acids. Okay, so here we will just look at what are the enzymes that are responsible and what is their function. That one we will be just checking it out. Okay. Okay. So in the process of splicing, what's there? Splicing. Okay, which enzyme is here? We are having SNPs. Okay, SNPs. That means small nuclear SNR. Sorry, U will not come. Just S. SNP. Okay, U is not there, right? SNR. Just SNP. Is not U won't come. Okay, so small nuclear ribosomal protein. Yeah, protein. SNP is there. Okay, so then after that, capping. Capping is done in the okay, at 5 prime. Okay, so in 5 prime what's happening? There is actually methyl methyl. OMG, with the spelling, why am I this much weak? Okay, methyl, yeah, very easy spelling. Sometimes I can easily write it, but sometimes it distracts, mainly in the board, on the board. Okay, methyl guanosine guanosine triphosphate is being added by, it is the thing that is responsible, it is being added by methyl guanylic LY. Okay, so it is being added by methyl guanylyl. As I said, I'm very okay. Guanylyl transformase. Okay, then after this we are having tailing. Okay, which is done at 3 prime. Okay, which is done at 3 prime. See, methyl guanosine triphosphate, methyl guanylyl transformase is there, right? Okay, like that we are here having the what we are having. Here amino acids are being added, right? Amino acids are being added. So which is adenine. Adenine is there, right? So this is being added. Which enzyme is responsible for this one? It is responsible like A. What A? Oh god, I'm copying up. Okay, so poly, since many amino acids, first poly, adenine, polyadenine polymerase. Now this name is very easy. Sorry, phosphorase, not polymerase, phosphorase. Okay, phosphorase. Polymerase, phosphorase. Similar, right? So you can remember like that also. Polymerase, and since it's just grouping, like that also you can remember, but it is actually phosphorase. Phosphate is, I think it's using phosphate. I think it is using phosphate. Like ATP. When ATP is being consumed, then we will be using the word called as ACE. So I think while for the addition of these amino acids, since it will be coming as ATP only, right? ATP only, right? It will be, so to add in this group, okay, to add in that exon group after capping, it will be using phosphate. Okay, it will be using phosphate from that ATP. So since it is using ATP molecule, and from that adenine alone is being attached, from that ATP, A is alone being attached, then remaining TP is being used as the energy. So we can say that it has poly A phosphorase. Okay. This is how the concept will be working. I'm sure because of the nomenclature, even you can find the functions. Okay, so we'll meet in another amazing video. Bye bye.